Hey everyone, another day, another DSA problem. So today we're going to be looking at 1833 maximum ice cream bars. So this was actually today's daily problem. I'm a little late to be making the video, but yeah, anyway. So let's look at what the problem is asking for. So it says that it's a summer day and a boy wants to buy some ice creams. So he goes to the shop, and in the shop there are n ice cream bars. So you get costs of length n, which actually has the cost of each of these n ice cream bars. And the boy has some coins, and the goal is that he wants to buy the maximum number of ice creams. And this question has explicitly told us that we have to use something called counting sort. So let's look at that. But I'm going to shift over here so we can actually go through the problem. Okay, so the problem statement is very straightforward. I want to give an analogy here so we can actually understand the intuition behind what the solution is going to be. Okay, so remember when you were a kid and your mom would give you, let's say, 10 rupees, and she'd say, you can go to the shop and buy some chocolates for your friends. And let's say you were somebody who had a lot of friends. So you go to the shop and you have 10 rupees. Would you go and buy the chocolate that was 10 rupees? Because if you bought that, you could only give it to one friend. Or would you look for something that was really cheap and get a lot of chocolate so that you could give it to all of your friends, right? So that is exactly the intuition here. If you want to maximize the quantity of something that you want to buy, you would obviously buy the cheapest one. And yeah, so as I've written here, for the maximum number of ice creams, should you buy the most expensive ones first? The answer is no. So you should always buy the cheapest ones first. And this will give you the maximum number of items. The intuition is very simple. So let's just look at why we're doing this. Okay, so let's say I have 10 rupees, and these are the cost of all of the chocolates at the shop. Let's say I went ahead and I bought the chocolate, which cost me 8 rupees, right? So I have 10 minus 8, I'm left with 2 rupees, and I was able to buy one chocolate. And with 2 rupees, let's say I can't buy the chocolate of 5 rupees, I'll go and buy the chocolate of 2 rupees. So 2 minus 2, I'm left with 0 now, and I've bought a total of 2 chocolates. But let's say I started buying the cheapest ones first. I buy this one, okay? So I have 9 rupees left. I bought one chocolate, and then I can go ahead and buy the 2 rupee one. I have 7 rupees left, and now I have 2 chocolates. Now, let's go ahead and buy this one. So I have 7 rupees, I can minus 5, I still have 2 rupees left, and I have bought 3 chocolates. Now the next chocolate is 8 rupees, and I only have 2 rupees left. So I go home, I go to my friends actually, I can give chocolates to 3 of them, and I can still have 2 rupees left. So this is the approach that we're going to be following. So our strategy, as I've stated here, is always buy the cheapest ice creams first. Now, the normal solution for this could be that we sort the whole costs array, and we actually start iterating through that and buy everything as long as we still have money. So that's one solution. So that would actually be O of n log n time. But the question, as we saw, has explicitly told us to use counting sort. So we're going to look at the counting sort approach here. Now, one thing which is worth noting is that in our constraints over here, so we are given that the size of the cost array, as in, the size of whatever these prices are, goes to a maximum of 1 lakh, right? So this is our range. And what does that mean? That means there are only 10 lakh possible prices of these ice creams to exist, all right? So here is what we're going to follow, right? These steps will give us our solution. So the first thing we're going to do is we're going to build a frequency array. And what exactly does this mean? So frequency array will be a size of 1 lakh and 1, actually, because we start from a price of 1. So what this is going to tell us is, let's say, frequency of 5. So it tells us how many chocolates do we have that cost us 5 rupees, right? This could be something like 3 chocolates. So we're going to do that, and we're going to map the cost with the quantity that is stored there. So the index is actually going to map to cost. Okay. So the second step is we're going to go through all of our possible prices, which would be from 1 rupee to 1 lakh rupees, right? So we're going to do that, and we'll start iterating through all of those costs. And then what do we do at each of these costs, right? So at each cost, we want to calculate how much can we possibly buy of ice creams that are worth this cost. Let's look at an example over here. So the cost that I'm at right now is 2 rupees. And I have 5 ice creams, which cost 2 rupees, but I have only 7 coins, right? So when I have 7 coins, can I buy 5 chocolates of 2 rupees? Because 5 chocolates into 2 rupees would be 10 rupees, and I only have 7. So how many can I actually buy in 7? So if 7 divided by 2, then I can actually buy 3, and then I'm left with 1 rupee. So I can buy 3, right? And we want to check that. So how many can I possibly buy of this cost will be either the total number of items that we already have there, or it's going to be how much can I afford to buy, right? So why this equation is there is, let's say the cost was 2 and the quantity of it was 1, right? And I had 7 rupees. So I just go and buy one, and that would be 7 minus 2, and I still have 5 rupees left. So in that case, the whole frequency itself becomes how much I can buy. That's why we have this equation. This is important. All right, and after we do that, we want to do this. We're doing this. We're iterating through all possible costs, right, from 1 to 1 lakh. So we want to update coins. So after I purchased that, I had 7 rupees, and I actually purchased 3, right? So how many was I able to buy? How many was I able to buy? That's stored in answer right here. I was able to buy 3 here, right? So I'm going to go ahead and add 3. Now, how many coins am I left with, right? So I initially had 7, and I want to subtract how many did I buy? I bought 3 ice creams, and they were each a cost of 2. So 7 minus 1 is equal 7 minus 6 is equal to 1. So coins gets updated, and this will be 1, and answer will be 3. Okay. So yeah, I think that's very understandable. So this is a simple problem actually, but let's go through a dry run to kind of remember the way we're going to solve the problem. Okay, so let's form our frequency array over here. Let's see. 1 for the cost of 1, I have only 1 ice cream. The cost of 3, I have 3, I have 1 ice cream, and the cost of 2, I have 1, 2, 3. I have 4 ice creams that cost me 2 rupees each. So I want to add 4. And then for 4, I have only 1 ice cream. And then we have 7, we have 1 ice cream. And we have 5 coins. All right, so as we said, we'll start from the cheapest first. Let's say for a cost of 1, we'll keep this answer here of how many total I'm able to purchase. And we'll have coins. Initially, coins is equal to 5. So I'm going to go ahead and buy 1 ice cream, which cost me 1 rupee. So I will be adding 1 ice cream. And then I'm subtracting 1 ice cream. Cost was 1 rupee. So 1 into 1, I will be remaining with the remainder is 4 coins left. Okay. So now I'm going to go to the cost of 2 rupees, right? So once I go to 2 rupees, I see that there are actually 4 ice creams costing 2 rupees. So that's 2 and 2, 4, which is equal to 8 rupees. But I only have 4 rupees, right? So I'm going to check in 4 rupees, how many ice creams of cost 2 can I buy? And this gives me 2. So I will add, I'll add 2 ice creams here. And then my cost would be 4 rupees subtracted by how many ice creams did I buy and what was the cost of those ice creams. And now we go to 0. So once we go to 0, we can just break through from this, break out from that. And 3 will be the answer of how many ice creams I'm able to get. So you can try out for this array and check the possibilities, and that is the optimal answer. Okay, so in terms of complexity, what did we do? We built a frequency list. So we went through 1 lakh possible costs, right? So that is going to be, sorry, we didn't go through 1 lakh. We actually went through cost of the ice creams that was given. So that's O of N. Okay. And the range of these prices, however, can go from 1 to 1 lakh, right? So that is going to be K because we are iterating through that later on. We're iterating through each of the costs. So we get N plus K. And then for space, because we are storing that frequency list, which is a size of actually 1 lakh, that's K. So 1 lakh is not actually a big amount. So we can, constants are dropped, but since it's given in the problem, we'll just let it be. Okay, let me code up this solution and maybe you guys will get a better idea. So the first step was we were going to have a frequencies list here, right? So this is 1, 2, 3, 4, 5. The fifth one is 1. So I'm adding an extra 1 because we're going to iterate from 1 to 1 lakh later on. So we want to have 1 extra value over there. So let's go through each cost for cost and costs, and let's update the frequency of the count of ice creams at that cost. Okay. Now what do we want to do? We were holding an answer variable, right? So let's iterate from for cost and range. So we were going from 1 rupee to 1, 2, 3, 4, 5. Okay, because this caps at 1 lakh Python thing. Okay. So one thing, we might go to a frequency, like we might go to a cost where there are no items there. So let's just write that. So if there are no items at this cost, then we just want to continue and go to the next cost. Okay. And now if there are items there, let's see how many I can buy. So as we saw, the amount that you can actually buy will be the minimum of how many items there are at that cost and how many I can possibly buy with the number of coins that I have. So coins by cost. Okay, and now we want to add that to answer, right? So this is how much I was able to buy at this price. And we also want to decrement coins. So coins will be how many did I buy, which is stored in can buy, and what was the cost of what I bought. All right, so there could be a condition like we saw in that problem over there where I run out of coins. Now, if I run out of coins, why would I simply want to iterate up to 1 lakh, right? So let's just make sure, let's just check that condition. So if coins ever reduces less than 0, then we can just break out of this. And at the end, we should be able to return answer. So let's write the time complexity for this was O of n plus k. So the step over here was O of n because costs is a value n. We don't know what n is here. And then, but we go in a range, right? So we know that this range can actually go from, it goes from, to 10 raised to 5, 1 lakh. So that's over there, n plus k. And then we have space, which is O of k, which is 1 lakh over here because of the size of this. If I haven't made any mistakes, this should run. Yeah, I have some issue. Index out of range. This is, I think it's something with the zeros. Okay, it's running fine. I accidentally added another 0. Anyway, this is running. I hope you guys understood the solution, and yeah, happy coding, everyone.